Hi friends, today we are going to see some of the problems which is frequently being asked in physics at IIT NEET examinations. So we will start with the topic called dynamics of particles, where we will see some definitions before going to the problems. Just to refresh for those who are those who have forgotten some of the formulas. Okay, velocity. Velocity is the rate of change of displacement of a body moving in a straight line. It is measured in meters per second. Velocity is a vector quantity. That is, it has magnitude and direction. So velocity is distance meter per second. It is represented by ds by dt or s by t. Acceleration is the rate of change of velocity of a body measured in meters per second square. So acceleration is change in velocity divided by time. So acceleration is represented by a is equal to dv by dt, is change in velocity divided by time. So velocity in the place of v, we replace it by ds by dt, which we got from velocity. So ds by dt, now we write it as d square s by dt square. Now this a is equal to, now we write it as dv by dt is written as a is equal to dv by ds into ds by dt. Now this dv by dt is rewritten as dv by ds and ds by dt. That is, if we cancel each other, it will be dv by dt. Now we are putting this ds, okay, in the numerator denominator to bring it into this form, dv by ds into velocity. Okay, so now we get a equal to dv by ds into v. The unit is now change in velocity by time. The velocity unit is meter per second. Now time unit is second. Now we have meter per second square. A is equal to meter per second square in SI units. A is equal to meter per SEC. It should be seconds is represented in SEC in MKS units. Please remember that. Velocity, acceleration, displacement relationship. Now before going to the problems, we have to just know some of the relationship formulas to solve the problems. Now we have consider a body moving in a straight line, and u is the initial velocity of the body and v is the final velocity of the body in meter per second. T is the time taken, time in seconds, during which velocity changes from u to v. S is the distance traveled by the body in time t. A is the acceleration of the body. So the equation for final velocity, change in velocity is final velocity minus initial velocity. That is, final velocity is v, initial velocity is u. Now this rate of change of velocity is equal to change in velocity divided by time. That is, change in velocity v minus u, that is final velocity minus initial velocity divided by time, is equal to a. Now when we rewrite it, at, okay, v minus u comes on one side and a into t gets multiplied and goes on the other side. Now we have we bring the u, which is on the right hand side, to the left hand side. That is, v is equal to u plus at. Okay, this is called as velocity time relationship. Okay, whenever there is a relationship between velocity and time, we have to use this formula to solve the problems. First of all, you must have seen the formula S is equal to ut plus half at square. Now we are going to see that is the displacement and time relationship. Now we are going to see how this equation is derived. Now average velocity is initial velocity plus final velocity divided by 2, which is equal to v plus u by 2. The distance covered is s is equal to average velocity into time. Now we have that is distance covered. S is distance covered. S is average velocity into time. That is the formula we have seen. That is u plus v divided by 2 into t. Now we are going to substitute v with u plus at, because we have found the formula in the previous derivation. S is equal to u plus, okay, u plus, instead of v we are putting u plus at divided by 2 into t. Okay, now we get u plus u, 2u plus at divided by 2 into t. Now we are just writing this, okay, separately, 2u by 2 plus at by 2 into t. Now this 2 and 2 gets cancelled and we get u plus half at into t. Now finally we write S is equal to, distance covered S is equal to ut plus half at square. This is the derivation for displacement time relationship, okay. Now we must have seen in books v square minus u square is equal to as, that is the velocity displacement relationship. Now we are going to see how this velocity, this formula was derived. S is equal to ut plus half at square, which we have seen here, which we got derived. Now S is equal to u into this t. We are replacing this t with the another formula in terms of v and u, now which we got from v is equal to u plus at. Now then at is equal to v minus u, then t is equal to v minus u divided by a comes to the denominator. Now we are using this t formula, substituting this t formula here in this place, and we are getting v minus u divided by a plus half a into v minus u divided by a, v minus u divided by a the whole square. Now since we have v minus u in both the places, we are bringing it commonly outside, then we have u by a plus half a v minus u the a square. Now we get cancel a and a, the numerator and denominator. Now we have v minus u by a plus half v minus u by a. So this v minus u, now we take the LCM. So what is the LCM? A plus v minus u by 2a. We take the LCM as 2a, and so we get 2 here, okay, then plus v minus u. Now S is equal to v minus u into we have 2u here and 1 minus 1u, that is we get v plus u. So v minus u into v plus u divided by 2a, which we get as v square minus u square by 2a. We write this as v square minus u square is equal to 2as, which is called as the velocity displacement relationship. Now using this relationship, we will try to solve some simple problems starting with, okay, then slowly we will move on to tougher problems. A cycle is moving with a velocity of 3 meters per second. After 4 seconds, the velocity of the cycle becomes 5 meters per second. Find the acceleration of the body or cycle, okay, acceleration of the cycle, okay, acceleration of the cycle. So the initial velocity, okay, of the cycle is 3 meters per second. The final velocity which we are considering is 5 meters per second, that time. Now they are asking us to find the acceleration. Now if you observe, we have seen already 3 formulas, so you may be confused which of the formulas to use, formulas to be used, okay. Now here in this problem, we have the problem is given, v is given, u is given, t is given, and they have asked us to find only a. So v is equal to u plus at is the only formula where you have all the parameters except a, and so it is easy to choose which are the formula to be used, okay. Now we have v is equal to u plus at, we put all the values here, 5, 3, a into 4, and we find a is equal to 0.5 meter per second square, okay. Now we will see the second problem. A bike is moving at a velocity of 30 meters per second. The bike is brought to rest by applying brake in 10 seconds. Determine the retardation, distance traveled by the bike after applying the brakes, okay. We have to find 2 things, retardation and the distance traveled of the bike after applying the brakes. Now in this we will see what are the values that is comes into the problem. The initial velocity is 30 meters per second, okay. Bike is moving with a velocity of 30 meters per second. the final velocity after the bike comes to rest. Now what is the thing we are seeing? The bike is brought to rest by applying the brake. Okay, so which means once the brakes are applied and when it comes to rest, the final velocity becomes 0. That's what here it is said. Okay, the initial velocity at which the bike is going is 30 meter per second. After applying brakes, it comes to rest, which means final velocity becomes 0. The time taken, okay, to apply the time taken after applying the brake and when it comes to rest is 10 seconds. Okay, now what is the first thing we have to find out? Retardation. First we will see what we will see that acceleration. We know that acceleration of the car is a. V is equal to u plus at. What is v? That is final velocity 0. Final velocity of the not car. Final velocity of the, we know the final velocity of the bike is 0 because after applying the brakes it has come to rest. Now the initial velocity of the bike is 30 meter per second plus a into t. Now we get acceleration a is equal to 3 meters per second square. But the thing is, we get the value in negative. Okay, acceleration is minus 3 meter per second square. So what this represents is this, so once we are applying the brake, this is called as retardation. General a, when a is positive, it is called as acceleration. When a is negative, it is called as retardation. So retardation means negative acceleration. Once a person starts applying the brake, the acceleration, okay, gets reduced. Okay, suppose a person is going at, say for example, 30 meters per second. It comes to he comes to the 27 meters per second, 24 meters per second, 21 meters per second. So the acceleration keeps decreasing, and then finally it comes to rest. So that's what it means. The retardation, the rate at which the bike comes to rest is the retardation. Okay, the rate at which the bike slows down is called the retardation, which is a is equal to minus 3 meters per second. The second question is the distance travelled by the bike after applying the brakes. Okay, after applying the brakes. Now that is the distance traveled. Distance traveled formula we know it is s. So we write the formula of s. S is ut plus half at square. Now u, what is the velocity at which the bike is going? 30. What is the time it comes to rest? After 10 seconds. Okay, into 10 plus half a we have minus 3 and t 10 square. Okay, now we multiply and we get 300 minus 300 by 2, that is 300 minus 150, we get s is equal to 150 meter. So the bike is going at 30 meter per second. So a person is applying brakes to the bike, and after 10 seconds the bike comes to the rest, and during this time the question is how much of distance has he travelled after applying the brake. So the person has travelled 150 meters after applying the brake. Okay.